You're now the proud possessor of the first edition in 2017 of Science in Action from the BBC World Service with me, Roland Pease, in which we hear about the life of astronomer Vera Rubin, who showed us there's more to the universe than meets the eye.
I discovered that the stars, as you went further and further out, did not slow down. They were moving just as fast as the stars near the center. And that was a surprise.
And evidence of still mysterious dark matter. And what could be more mysterious than a moving magnet?
Every little town along the way, there'd at least be a few people out on lawn chairs trying to spot the magnet as it traveled by.
It was 20 metres across, though. And how puny prawns may be a solution to a persistent problem of riverborne parasites. But some bright spark thought we should start with a flash in the pan that happened far, far away in the universe.
I think of them as these flashes of radio waves. It sounds like a little bit of a sizzle. It's like you're tossing a hot piece of food onto a frying pan or something like that. There's a zzz to it.
Except it was far, far quicker, just 1,000th of a second long. That's so brief that radio astronomers had completely failed to notice them until last decade, in a discipline that's used to following the steady twinkle of eternal stars. An event that's over almost before it began is hard to take on board, particularly as whatever made it may well have destroyed itself in the process. Which is why the discovery of one of these mystery fast radio bursts that flashed again and again over a matter of months was a real game changer. By persistently watching that space with better and better telescopes, Cornell University's Shami Chatterjee and a host of colleagues have begun to crack open the mystery.
The story begins with these flashes of radio waves, and most of these were one-off events. And because they're so brief, they're really, really hard to find, because with a radio telescope, you're scanning only a tiny patch of sky at any given point in time. It's hard to find them. So far, we know of about 20 of these events all over the sky, and yet the rate we infer from these 20 that we've detected is that there must be 5 to 10,000 of these flashes going off all over the sky every day. So far, we only have detected a total of 20 or so of these sources.
And each of these flashes is a bit like, I guess, a car backfiring in a busy street. You know something's happened, but you don't know which car it was, and that's what you're trying to chase down with your radio astronomy.
That's exactly right. You see this flash, but because you're seeing it with single-dish radio telescopes, which have fairly coarse resolution on the sky, within that patch of sky, there's dozens and dozens of radio sources, hundreds of galaxies. We don't know where it was coming from, so we can't tell how far away it came from, what its energy was, or much else about it.
And the point is that you've discovered one object which has flashed more than once.
Right. And so this made the story a lot more interesting. I don't exaggerate when I tell you that there are more theories for what these things could be than there are observed bursts.
I'm not surprised. I've talked to astronomers before.
Yeah. So there's many more theories about what it could be. But when we reported last year that one of these objects was repeating, that basically at one go knocked out about half of these models, because for this one source at least, we knew it couldn't be explosive. It had to be something where the engine that produced this survived for the next flash. And that immediately took out about half of the models, but it still left behind the mystery of what it actually was.
And when you say it was repeating, I mean, this is repeating several times a second like a pulsar or, once a year?
Quite on the opposite end of the spectrum, not at all like a pulsar. We spent hours observing this, and every couple of hours, if we're lucky, we get one flash. And that's when this source appears to have moods, if you will. Sometimes we get flashes. Other times we observe session after session and we see absolutely nothing.
It must be utterly baffling, but it does mean that you can start looking in a single place and look for what else is happening there.
That's exactly right. The fact that it repeats gives us some idea that, okay, look, this is a good spot to go fishing with a much higher resolution telescope.
So what is the news that you've got this week?
We went fishing in this spot with the VLA, the Carl Jansky Very Large Array in Socorro, New Mexico. And we have actually captured several of these bursts with the VLA's pinpoint resolution.
And what does that tell you?
One of the first things we found is that we now have a persistent radio source, a radio source that's steady, slightly variable, at exactly the position where these bursts are coming from. So whatever is producing these bursts, that persistent radio source is a representative of that object.
So if we go back to your frying pan analogy, this would be like seeing the heat from a hot frying pan, and then you're getting splashes, as it were, as you throw a piece of bacon onto that frying pan.
That's a plausible analogy. We don't quite understand what this persistent radio source is. This persistent source could be an active galactic nucleus, a black hole at the center of a galaxy that's feeding, putting out jets, and these sizzles that we see are little bits of plasma being vaporized in the jet. That's one possible interpretation. It's not one that we favor. Instead, the interpretation we favor is that maybe it's a baby magnetar, a neutron star with a massive magnetic field, and it's got a nebula surrounding it that's powered by the energy being lost by this object. And every once in a while, we are getting a flash from this baby magnetar. That's a possible interpretation.
So, I mean, you've seen it flash, you've seen it sort of radio glow. Presumably what you'd really like to see would be some light or some other kind of energy coming out from this source.
That's the next thing we're reporting today, is that in our observations, once we pinpointed exactly where it was, we observed with the Gemini optical telescopes, and we found a faint smudge of light. And that faint smudge of light turns out to be a dwarf galaxy. And once we take a spectrum of the dwarf galaxy, we can measure spectral lines and we can find out how far away this galaxy is. This little dwarf galaxy turns out to be 3 billion light years away. So the light from this galaxy has been traveling for 3,000 million years before it gets to us.
And in a way, there are 3 units that I use in astronomy stories. It's somewhere in our galaxy, it's somewhere in a neighbouring galaxy, or it's off towards the edge of the universe. And it's the last of these kind of measures.
It is closer to the edge of the universe than it is to our galaxy or a neighbouring galaxy. That's absolutely right. It's at a cosmological distance.
That means these little sizzles you're hearing every few hours or something must be phenomenal energy.
That's right. That's one of the most fascinating things about this. Till now, we had a lot of conjectures about how much energy there is in these flashes that we see because we didn't know how far away it was. And today we are reporting without a shadow of doubt, they are associated with this little dwarf galaxy 3 billion light years away. And so that means the energy associated with these flashes must be huge. But remember, they only last a millisecond.
But what a millisecond. So bright, we can still see it 3 billion years later. I was talking there to Shamit Chatterjee just before the American Astronomical Society press conference where he announced the discovery to the world. There's a link to his Nature paper with the detailed analysis on our webpage at bbcworldservice.com. John Amos, science correspondent, is with me. John, there's something really wonderful about a discovery like that.
Yeah, and it's a detective story as well, isn't it? That's what I like about it. But in time, it seems like they are tracking it down, and it won't be long before they're able to have a look at the sources and kind of work out what flavour they are and what type of object is emitting them.